Our gut microbiome has a profound impact on our health. In the past decade, gut microorganisms have been shown to play a role in a wide range of human diseases, including diabetes and obesity. The gut microbiome is made up of all the microbiota that live in our intestinal tracts, including the stomach. Most, however, hang out in the colon, the longest part of the large intestine. These minuscule organisms, especially bacteria, help the body break down carbohydrates, proteins, and sugars into useful nutrients and process fiber in the colon. Everything we eat and drink, and we don't digest and absorb, goes down through our intestinal tract to our distal intestine, to our colon, where the majority of the microbes are, and becomes food for the microbiome. 𝐁𝐢𝐨𝐴, Cleveland Clinic Children's. They help protect the body against invading pathogens, activate the immune system, and digest food, to name just a few functions. Most gut microbes are helpful, while others are harmful. But even favorable microbiota can cause problems, like yeast infection or disease, if they're out of balance. At the same time, it is now understood that diet plays a significant role in shaping the microbiome, with experiments showing that dietary alterations can induce large, temporary microbial shifts within 24 hours. Given this association, there may be significant therapeutic utility in altering microbial composition through diet. For example, it has been shown that a high-fat diet adversely reduces beneficial bacteria. More complex relationships between gut microbiota and health exist too. Numerous studies have shown that the excess or lack of certain bacteria in the gut have a strong correlation to the onset of diabetes, type 2 DM. Consuming fiber, for instance, can increase microbiota diversity, reduce blood glucose levels, and help people maintain a healthy weight. Pre- and probiotics can be very helpful in aiding gut flora diversity. Prebiotics, in contrast to digestible carbohydrates, non-digestible carbohydrates such as fiber and resistant starch are not enzymatically degraded in the small intestine. Rather, they travel to the large intestine where they undergo fermentation by resident microorganisms and are able to modify the intestinal environment. This property of fibers warrants their additional designation as prebiotics, which by definition are non-digestible dietary components that benefit host health via selective stimulation of the growth and/or activity of certain microorganisms. A diet low in fiber has been shown to reduce total bacterial abundance. Consuming fiber can increase microbiota diversity, reduce blood glucose levels, and help people maintain a healthy weight. Probiotics, fermented foods containing lactic acid bacteria, such as cultured milk products and yogurt, represent a source of ingestible microorganisms that may beneficially regulate intestinal health. In studies, the HDL cholesterol and insulin sensitivity improved after probiotic supplementation. Besides immunity, gut microorganisms have also been shown to impact host metabolic health. Individuals with metabolic disorders such as obesity and diabetes, type 2 DM, have been shown to have intestinal dysbiosis in relation to healthy individuals. In conclusion, review of the literature suggests that diet can modify the intestinal microbiome, which in turn has a profound impact on overall health. Clearly, our gut microbiome has diverse effects on host immunity, and a balanced gut flora is critical for a healthy immune system. Maintaining a healthy gut microbiome is critical to human health. Metformin and diabetes. Various in vitro and in vivo studies demonstrated that metformin might exhibit glucose-modulating effects by interacting with the gut microbiome and has been evaluated in various clinical trials. In this regard, some scientists have also investigated the relationship between metformin and the gut microbiome in the modulation of inflammation, gut permeability, glucose homeostasis, and abundance of short-chain fatty acids, SCFA, producing bacteria. Metformin treatment promotes mucin production, which might recover the increased gut permeability induced by high-fat diets or metabolic disorders. Several studies in T2DM have reported that metformin modulates inflammation, and have shown that the alteration of microbiota due to metformin treatment was related to the modulation of inflammation. The mechanisms are not currently understood. Thus, future studies are warranted to unveil how metformin mitigates the debilitating effects of T2DM by the alteration of gut bacteria. Global diabetes-related health spending continue to grow rapidly. It was $760 billion in 2019, approximately 10% of total global health spending, and is expected to reach $825 billion in 2030 and $845 billion in 2045. Only a long-term, healthy diet can truly maintain or improve your gut microbiome. Experts recommend eating foods high in fiber, like complex carbohydrates found in grains, vegetables, and legumes. You should also incorporate fermented foods, such as kimchi, kefir, kombucha and sauerkraut, which contain their own probiotics. Adding a beneficial probiotic supplement to your diet can be a help as well in achieving and maintaining gut microbiome balance. And keep sugar intake low and combine it with fiber, like eating your fruits instead of drinking them in juice. With more understanding of the importance of whole foods in your diet, exercise and adequate sleep, we can reverse the increase in T2D, M. Let's beat diabetes.